Let me show you an experiment I'm working on. One bag, I've got water. I've sealed it. The other bag, grass clippings. I've sealed that. What I'm going to do is I'm going to put this both outside for 3 hours, and then through the magic of video editing, we're going to see what happens to each of these over that time. I'll be right back. In the last video, we learned that you can find relative humidity if you understand the vapor pressure and saturation vapor pressure at any given temperature. Finding saturation vapor pressure is actually kind of easy. It's finding vapor pressure that's the hard part. Well, instead of going through that confusing route of trying to figure out what the relative humidity is, there's 4 steps that you can do as a scientist. Step 1 is you find the dry bulb temperature. Step 2 is you find the wet bulb temperature, and then you subtract the dry from the wet from each other. You then take that difference and you use the chart. Now, the chart I'm talking about is the file you should have downloaded before starting this video. If you haven't done that yet, please press pause on the video, go get that file, and then open it up and follow along with me. Let's look at this chart and go ahead and do an example. Let's say you calculate that the actual temperature of your air is 56 degrees. Well, the number's on top, that's your dry bulb temperature, so we're going to use this column right here for 56 degrees. Then you go ahead and you measure the wet bulb temperature at 52. That's 4 degrees difference. 56 minus 52 is 4. So now we're going to use this row right here. And where they meet, that's your relative humidity. So as you can see in that example, if the air temperature is 56 and the wet bulb temperature is 52, we have a relative humidity of 75%. Let's do another example. Let's say that you measured the temperature and it's 70 degrees. So we look at the top of the chart and, I don't know, what do? There's no 70 degrees. There's just 68 and 72. Well, here's where you're going to have to estimate. 70 is between 68 and 72. So we're going to go ahead and look at both these columns, and you'll know that the correct number is in between. So then you go ahead and you figure out that the wet bulb temperature is 63. Well, 70 degrees minus 63, that's a 7-degree difference. So we find the row that's 7 degrees different, and we look at that row, and we know it's somewhere between 65 and 67%. Since 70 degrees is right between those two numbers of 68 and 72, we'll have to estimate that the relative humidity is 66%. So those are the 4 steps you must go through in order to figure out relative humidity. But no matter which way you do it, whether you use the saturation vapor pressure method or whether you use this method right here, relative humidity changes with the temperature. And that's very annoying because the temperature, as you know, changes constantly depending on the height above the ground, what surface you're over, and what location on the earth you are. So relative humidity is constantly changing throughout the day. To measure the humidity outdoors, we use a device called a sling psychrometer, which I'm going to show you here. It involves 2 thermometers, one's wet and one's dry. So right here's my sling psychrometer, and you notice right there on the bulbs, one is dry and one is wet. And the idea is we're going to take this and we're going to dip it in water like so. So this is the dry bulb right here, and even though it's coated in water, if I sling it around my head, it's like putting a fan on it. The water on here will evaporate. That will make the temperature go down, but once the evaporation is complete, it will go back up to the air temperature. The bulb with the little sock on it, the wet bulb, is going to stay wet. But as we blow air through it, it's going to cause evaporation, which will cool this second thermometer down. So both thermometers there will be in use, and all you have to do is take this and sling it for 30 seconds. Have my clock back there. Time's up. Let's see what happened. Taking our look at our 2 thermometers, you can see that the top one, which is the dry bulb, is at 68, and the wet bulb on the bottom is at 60 degrees. So that's great. We have a dry bulb temperature, we have a wet bulb temperature. We can find the difference and go ahead and check out the relative humidity there on your chart. We had 68 degrees as the dry bulb, 60 degrees as the wet bulb. So looking at our chart, 68 degrees, we're going to use this column right here. And we had an 8-degree difference, so the relative humidity in this room right now is 60%. The psychrometer is also an easy-to-use tool because built right into the front of it is its own little chart that we can also use to calculate the relative humidity. But just like the temperature fluctuates, the relative humidity does that as well. So let's go outside and see what it's like out there at this time. 25, 26, 27, 28, 29, 30. So it's warm out here. My dry bulb says 82. My wet bulb says 66. Depending on where I am out in the outdoors here, we're going to get a different relative humidity because the temperature changes so rapidly. Remember that experiment we started? Well, it's been 3 hours already. Well, the bag that just has the water in it, there's not much in there at all. But there's a pretty good cloud in the bag that has the grass clippings in it. You know, when we exhale, we give off a lot of water vapor in our breath. Just like the plants have a lot of water tied up inside of them, and they release a lot of water throughout the day. We call that transpiration. An acre of corn, according to the USGS, can give off between 3,000 and 4,000 gallons of water vapor a day. So it's obvious that the terrain you're over is going to have an effect on the moisture content in the area where you are. Relative humidity is very complicated and it changes very, very quickly. There are better ways of measuring the overall humidity of the air.